Lesson 90, sets. So first off, a review of sets of numbers. Here we have a set, which is just a collection of elements. So a set could be anything, it could be numbers, it could be objects, but they all have something in common. Sets are listed in braces, so this is what you see as the braces. And then the ellipses, the three dots, often used to show that the numbers of set never ends. So it continues whether it's to the right or to the left. And then common number sets, we have natural numbers, so 1, 2, 3, and then it just keeps going. We have whole numbers, means it starts with 0 and then all the natural or counting numbers. We have integers, all positive and negative whole numbers. We have rational numbers, all those numbers that are integers, but they can also be written as fractions and decimals that end or repeat. And then we have irrational numbers, which means you cannot write them as a fraction. They are decimals that never end and they never repeat. And real numbers, all numbers are real numbers. And then you have complex numbers, which we're not going to deal with today. So first problem, use a set notation to denote the set of even integers. All that is telling you to do is just write a set of numbers. Put our braces down. So a set of even integers. Remember, integers are positive and negative whole numbers. So I'm just going to put an ellipsis because it can go to the left, and I'll just have -4, -2, 0, 2, 4, and then ellipsis and brackets. So that would be a set notation that denotes a set of even integers. And the number of numbers that you put in there, it can vary. I mean, you could do 3 of them as long as you put the ellipsis at the end of both sides, and you would be good. The next one, use set notation to indicate whether each number is an element of a set of rational numbers. So we would use like the curved E like that to show that it is an element of the set of rational numbers. So 2 can be written as a fraction, so we could say 2 is an element of rational numbers. The next one, half. Half is a fraction, so that could be written as a set of rational numbers, or as an element of rational numbers. And the square root of 2 is not. So I just put the slash through there and then put rational numbers in the braces because it's not a rational. It would actually be irrational. Next one, indicate if the number is an element of the set of integers. We're going to do the same thing, just we're going to be dealing with integers here. So -1, it is a set of integers, because integers are positive and negative whole numbers. Two is an element of integers. Square root of 3 is not a set of integers, because that would be irrational. Next one, use the subset symbol to show the relationship between A and B. So the subset symbol would just look like this. It looks like a C. So we want to say, use the symbol to show that the relationship between A and B. All triangles in set A and all polygons. Well, triangles are polygons, so we would say that A is a subset of B. The second one, we have real numbers. Real numbers, and Q stands for rational numbers. Here we'd say that B is a subset of A because rational numbers are a subset of real numbers. And the third one, vowels. A is vowels and B's are letters in the alphabet. So we would say that A is a subset of B because vowels are some of the letters in the alphabet. Sample problems 3 and 4, graph the elements of each set on a number line. So a set of integers. So we could have -5, -4, -3, -2, -1, 0, 1. And I have the arrows on both sides just to show that they continue to going in both directions. To graph them on there, I can just put points on each of these. And there I graphed a set of integers. I could have done a few, but it's important that you put these arrows at the end to show that it continues. There are integers to the right and to the left of that one. And this last one here, draw a number line. So we'll have -1, 0, 1, 2, and plot these on our graph. I know the square root of 4 is 2, so I can plot that one down. Square root of 3. Square root of 3 is less than 2, so I'm going to put that here. Square root of 2 is still more than 1, so that'll be right here. Then we have the square root of 1. Square root of 1 is 1, because 1 times 1 is 1, so I would have it here. So this should be square root of 4, this is the square root of 3, this is the square root of 2, this is the square root of 1. Next one, it says use the subset symbol to show the relationship between the sets of natural numbers n and integers z. I would say natural numbers is a subset of integers because integers are made up of natural numbers or whole numbers counting or positive and negative, and natural numbers are whole numbers minus the 0. And the last thing we want to look at are Venn diagrams, just an illustration showing the relationship among sets. So we have intersections and we have unions. And here are some of the set symbols that we can have in dealing with sets. We've already used some of them. This one here, a subset. We use the braces. We use the curved E as the element of. So now we're looking at the intersection and union in empty set. Intersection just means elements are in both sets. So you have the upside down or the N-shaped symbol, and then union combines both sets, so every element is part of it. And you have the upside down N or the U. If you look at a Venn diagram, what's the same in both? That would be the intersection. And then for the union, it would be in every element in both A and B. Let's take a look at an example here. Sets A and B are shown below. Find the intersection and union of A and B. So intersection of A and B. So what numbers do we have in common in both sets? Well, they both have a 2 and they both have a 4. So that would be the union, or the intersection. And then the union of A and B. We just need to list all of them. So 1, 2, 3, 4, 6, and 8. Even though some of them repeat, you only put them down once. Next, we'll use a Venn diagram to illustrate the sets and then find the intersection of A and B. So in sets, n, remember, is natural numbers, so 1, 2, 3, 4. So 1, 2, and 3 are in both of these. That's what you have in common. Here you'll have way more numbers in this over here, so we can continue on, but we don't need to put those in there. We're just trying to find the intersection of those. And so the ones that are in common would be 1, 2, and 3. If you were to put more numbers in there, you would just say, you can continue this with 4, 5, and the ellipsis. That would be our Venn diagram right there. The other one says, find the union of this here. So let's draw our Venn diagram. And the Venn diagram can look in different ways. This would be our A, this is our B. So A, we have a 2, we have a 4, and we have a 6. And the B, we got 1, 3, and 5. You'll notice that there's nothing in common. So we would say that the intersection of A and B would be an empty set, or you can just put a 0 with a slash through it. Up here, the intersection of A and B, we would just say 1, 2, and 3. Practice problem C, use a Venn diagram to illustrate the sets A intersection B. Here, so I'll have a Venn diagram. This is A, this is B. So 3 in A, 6 is in A, 9 is in A, 12 is in both. We have a 5 in B, got a 15 in B, we have a 20 in B. So we would say that the intersection of A and B would be 12. And the other one, we got all parallelograms and we have all trapezoids. So this one would be parallelogram, and these would be trapezoids. You notice I did not put anything in the middle because there's nothing in common. There's not a parallelogram that's a trapezoid, nor is there a trapezoid that's a parallelogram. So they have nothing in common. And our last one, use a Venn diagram to illustrate and find sets union of A and B. So I'll have my Venn diagram over here. This is A, this is B. So we have 10 in A, 20 in both, 30 in both, 40 in B. So we would say that the union of A and B, so I'll list all of them, so 10, 20, 30, 40. And the last one here, this is our A, this is our B. We have 2, 4 in the middle, 6, 8 in the middle, 12 here, and then we'll just put the ellipsis. So A union B, what do they have in common? Actually, just joining all of them together. we would have 2, 4, 6, 8, and we could just continue with the ellipsis because it would keep going because we're just listing all the elements in both sets. That is our lesson today on sets.